Experiment 10, Redox Reactions. This is a Camosun College chemistry experiment performed on June 16, 2020. You will need to follow along with your lab manual and answer the questions such as give the balanced chemical equations and what is oxidized and what is reduced. For this, you will need to review redox chemistry. Part 1, Oxidation of Metals. In this experiment, you will observe the reaction of magnesium with oxygen and iron with oxygen using a Bunsen burner to ignite the metals. At the end of the video, answer the questions in the lab manual. Write the balanced chemical equations for these reactions. First, turn on the natural gas line. Notice that it is parallel to the line of flow. By taking a small amount of steel wool with tweezers and lighting it on fire, watch what happens. What is the reaction? Write the balanced chemical equation. Now take a small strip of magnesium and light this on fire. What do you notice? Experimentally, I would not stare at this very bright light. It is very intense. There is a white residue, and this is magnesium oxide, MgO. Write the balanced chemical equation. When done with the Bunsen burner, turn off the gas flow. The tap is perpendicular to the line of flow. In part 2, this is the reaction of metal with water. Is this reaction an oxidation or reduction of the metal? What metal would be the most reactive? What is causing the bubbling? At the end of the video, answer the questions in your Chem 110 lab manual for this experiment. As you can see, these test tubes are filled with water. Placing copper in water, or zinc in water, or magnesium in water, nothing happens. But placing calcium in water, notice that there is bubbling. What is this gas? You will notice that a white cloud of particles are present. This is calcium hydroxide. And if you were to use litmus red paper, the paper will turn blue. Let's start over again and add calcium to water. The bubbling is hydrogen gas. We could light this on fire. Ready? On 3. 1, 2, 3. Part 3 is the reaction of metal with strong acids. The general equation for metal reacting with hydrochloric acid is given here, where the product is a water-soluble salt of the metal and hydrogen gas. For this part, calcium is way too reactive and will not be used. Copper is unreactive with hydrochloric acid even at 12 moles per liter concentration, the highest possible in water. So 6 moles per liter hydrochloric acid will react with magnesium and zinc. 6 mole per liter nitric acid will react with copper. Care must be exercised in handling these acids. They are very corrosive and cause serious burns. At the end of this video, answer the questions in your lab manual for this experiment. First, let's prove that copper is unreactive in 6 moles per liter hydrochloric acid. Now let's add magnesium to 6 mole per liter hydrochloric acid. Notice the reaction is very violent. The gas that is bubbling is hydrogen gas. Let's light this on fire. Ready? On 3. 1, 2, 3. Watch what happens to zinc in 6 mole per liter hydrochloric acid. Is this more reactive or less reactive than magnesium? For this reaction, there is not enough hydrogen generated to light this on fire. Now finally, let's react copper in 6 mole per liter nitric acid. The reaction will take a few minutes, but take a look at the solution color. You might also notice a brown gas. This is nitrogen dioxide, and not to be confused with nitrous oxide, which is laughing gas. Nitrous oxide has a formula N2O. Nitrogen dioxide is a toxic gas responsible for smog due to pollution from burning of fossil fuels in cars and power plants. This is why I have a cap on the test tube. At the end of this video, answer the questions in your lab manual for this experiment. Part 4 is the reaction of metals with salts of different metal ions in aqueous solution. The purpose of this part is to establish an activity series, rank in order of decreasing ease of oxidation. Which metal loses electrons more easily? Magnesium, copper, or zinc? There are 6 reactions required. Table 1 gives the reaction of the metal ions with the metals required. A reaction may or may not occur, and careful detailed attention will be required. Let's begin. On the left, magnesium metals add to aqueous solutions of zinc 2+ and copper 2+. In the middle, copper metal is added to aqueous solutions of zinc 2+ and magnesium 2+. And on the right, zinc is added to aqueous solutions of magnesium 2+ and copper 2+. It will be important to determine if there are any signs of a reaction, the metal turning black, or if there are any bubbles. Remember, there is an exchange of electrons if a reaction occurs. The metal will turn into ions, and the ions will be solid. Structurally, the solid will not be intact. Magnesium in copper 2+. Notice the black deposit that fell into solution. Zinc in copper 2+, there's a black deposit on zinc. The reverse, copper solid, doesn't appear to react at all. Now you could decide whether magnesium reacts in aqueous zinc 2+, or zinc solid reacts in aqueous magnesium 2+. Maybe having the metals out of solution might help. Here on the purple surface, on the top of the page, this is what the metals look like before reaction, and at the bottom, this is what the metals look like after the reaction. The ions that reacted with the metals are listed above, and the reacting metal are given below. Give the net ionic reaction for the reactions that occurred. there should be 3 net ionic reactions. Answer the question from the lab manual for this part of the experiment. Part 5 is the reaction of halogen with a halide ion of a different identity. Iodine in dichloromethane, which is also called methylene chloride, is red to pink in color. Chlorine in dichloromethane is colorless. The reaction is given here. Chlorine reacts with potassium iodide to give iodine and potassium chloride. Is this reaction reversible? You will need to know the difference between an oxidizing agent, a reducing agent, and what element is oxidized and what element is reduced. What is the oxidizing agent? Note, dichloromethane or methylene chloride is water insoluble and more dense than water. It is important not to dump dichloromethane down the sink. Dichloromethane has 2 GHS symbols. Do you know what they mean? I added about 1 ml of chlorine water to this test tube. This is about half a pipette full. Then I added 1 ml of dichloromethane, which is also called methylene chloride. Let's cap and shake. Notice that there are 2 layers. The top layer is aqueous, water layer, and the bottom is the organic layer. Now let's add in the reactant. I added 1 ml of potassium iodide. Let's cap and shake again. Notice that the bottom is now colored. What happened? This is the color of iodine in dichloromethane. Let's see if the reverse reaction will occur. If successful, then chlorine should be produced, and remember that chlorine is colorless in dichloromethane. First add iodine to the test tube, then dichloromethane. Cap, shake, and notice that the color is that of iodine and dichloromethane. Now, add the reactant, potassium chloride. Cap, then shake. Oh, the color remains the same. What can you conclude? Now you could answer the questions in your lab manual for this part of the experiment. To know the difference between an oxidizing agent, a reducing agent, and what element is oxidized and what element is reduced. What is the oxidizing agent?